Hello there. Welcome back. Today, we're gonna work on this. Well, not on this physically, but the software that will be running on this right here. It's ASP wemos pt1 mini, yes. And this is a battery shield. In the case, we have some 18650s which are hooked up, which means you just hook that in there and it starts to blink. Yeah. So now I recently learned about OTA, or over the air updates, which Arduino and the ESP is capable of doing. So what we're gonna do, we're gonna plug this ESP in and we're gonna upload a bootloader of sorts so that it can handle oh boy, really. Well, that USB cable is shit. I'll instead grab this one. There we go. That works. So I haven't actually prepared anything at all, so we shall see how this will go, because I know I have to create a new yeah, I was messing about with Arduino OTA and stuff. Yes, we shall create a new, and we shall do check stuff. Yes, what we will do, hashtag include Arduino OTA.h, and in our setup we will, let's refer to the documentation. Okay. Is there no like documentation? DuckDuckGo, is this a case of you like being stupid, or does it like not exist? It seems like it does not really exist. Well, Arduino OTA. I love that. I literally found this yesterday. Why can't I find it today? Okay. So what we need to do is that we need to do Wi-Fi begin. Oh yeah, maybe that's a credentials file I should copy over. Ooh. Let's copy that over. Let's save this as biometrics platform. And we will, there it is, and we will, yeah, here I have a credentials file, which I will copy. Well, that's reassuring. Replace it. Open Arduino again. Work. This is such a mess. You shall go dead. I'm just gonna assume that it works. So we have OTA, but before we can use OTA, we actually need the Wi-Fi. And after all that, we need the credentials file. So Wi-Fi file begin with SSID and password. What? Shit. And while, basically while Wi-Fi dot. Why do you interrupt my typing like that? Wi-Fi status is, so while the Wi-Fi status is not equal real connected, we will sleep. No, we will delay. That's the right term. About 100 milliseconds before checking again. Why not? Doesn't really need to be snappy. So we now have Wi-Fi. We can now start the OTA updates things. Actually, I could like flash the LED while connecting and crap, I guess. Well, we can demonstrate that later by adding it over there. But after we are connected to the network, we need to do something with Arduino OTA. I think we gotta say set host name, and this is gonna be the name your thing shows up as. So I'm gonna just say biometrics platform for that. And we're gonna do set password, I guess. And no. Is pass better than password as a password? Big philosophical questions. I mean, I don't want it to leave it open, just in case, but you're all watching, so I know I'll just set this to test for now. Arduino OTA. Now we need to do a setup or something like that. Or like, yes, we need to begin. I think, not sure. And then in our loop, we need to do a handle. Please compile, please compile, please compile, please compile, please compile. Please compile? Are you shitting me? Are you actually compiling the whole way? I didn't do a single error? Are you shitting me? I was guessing for most of this. How is this correct? Compiler, you must have found something wrong. Are you sure? Well then. Apparently my memory is better than I remember. But that's a counterintuitive meaning to say. Anyway, let's upload this. It is currently connected to my PC. Oh yes, I should probably take some more attention to OBS. But yes. Yes. There we go. This is the small little bootloader code we will need. I think this is all that we need to get the OTA up and running. It is uploaded now, so let's see if it appears. There it is. Biometrics platform at 192.168.0.18. And we should be able to upload to that. Let's disconnect this from the computer. You probably heard that. I didn't because, oh well. Let's, has it disappeared now? No, it's still there. Oh, what? 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 Okay, right. I was like scared for a second because it didn't blink, and then I was like, is it dead? But then I remember that, yeah, we just uploaded some code to it. But I can't see whether it's working or not now, so let's upload some code to it over there as it's sitting here. And yes, right here. It should still be here. Yes. So let's make it set up its pins or something. Pin mode, LED, built-in output. Now modify this while loop so we're blinking. That's gonna turn it on. That's gonna turn it off. Let's have it blink every time it does the OTA handle. So put it low on the handle and set it high again after. Sure, let's add a delay of 100 into the loop. Or like possibly half a second. Sure. That's selected. So this is weird, like this is battery powered. It's all like there's no wires, nothing. And it's literally just going to work if I play my cards right. Is it done uploading? Okay, yeah, there you go. It uploaded. Now it's connecting to the Wi-Fi, and now it's handling the OTA. Like I just updated this wireless device, and it can be anywhere in my house, and just ponk updated. It's just wow. Yeah, that's over there handling is really not that much. Maybe a millisecond or two. Seems a bit variable given the brightness. Yeah. Oh well. Sadly, there is no serial monitor over network ports yet. Even though you could technically add it, like as a software thing in the handle command, that it also like reads the serial buffer and acts as the receiving device, even though it's on the same microcontroller. Basically, have a software emulated serial. And just swoosh the buffer over somehow. Granted, I have no idea how this protocol works, but yeah, should be possible in my eyes. And then again, I didn't design any of this in the OTA system, that is. But yeah. Also, this case, that black dot there, that's where the charging is going to be. I'm going to drill a hole there. After that's done, I can basically stuff this down there for good and just forget about it. Although I might have to add a kind of spacer block here underneath the antenna here, because otherwise when you push it, it kind of tilts it maybe in there. It pushes it up maybe. I'll see how that works. But yes. Just adjust some parameters. Weird. Oh, yeah, it's now in the OTA, so it is on. Oh, it's not. Now it's connecting. And now it's just checking OTA again. Nice. Yes. I probably need to specify A0 as input. I don't really want to set it up in the loop because just from looking at the LED, the intensity is variable. Sometimes it's very small bright dots. Sometimes it's a clearly bigger, either just as bright or even brighter dot. So there's clearly some variance in this handle here. And I kind of want a stable time frame, and this kind of fucks that up. So, how do we fix that? Well, oh no. Oh, maybe. We shall see. Let's see what kind of interrupts we have available to us. ESP8266 interrupts and timers. Okay, interrupts and timers, yeah. So that's timers. Here's the thing. In my experience, running timer 1 or any kind of hardware timer on the ESP with Wi-Fi enabled tends to get a bit muckery and why you don't work kind of deal. I mean, that depends on how granular I need it to be. I mean, I need at least 10 hertz of granularity. to at least 20 times a second I need to read manually, which is not that fast. I mean, I could round it up to 30 or something like that even. I think software timer is good enough for 30 checks a second, which means we're gonna let this free roll, I guess. We're gonna have some variables called long, last reading, I guess. Let's make an unsigned on, just to tell the compiler exactly what we mean. So, what we need to do now? Well, basically, we need to do a software timer check. So if or something, and like, first off, 1000 milliseconds is a second. Let's divide that by first 30, 33, okay. How about 20? So 50 milliseconds between each. Or 25 milliseconds. It's 25, yeah, 25. And not 30, about 35, you know. Yeah, we can do it 50 times a second. Let's set up an interval for that as a define. Reading interval ns, not Microsoft milliseconds. I'm gonna have that be 50 milliseconds. Hey, the birds are waking up. Actually, it should have woken up quite a long time ago. Oh well. Let me quickly check that. Yep, not a single soul, just as always. Anyway. Let's do this timer check. So first of all, I think the millis returns along, not entirely sure. Mils equals millis. So there we just like get the current value. The thing is, this technically this isn't a software timer. Well, it is a software timer built on a hardware timer, because this millis function here is actually driven by a timer interrupt. The more you know. But yeah, this is still a software timer because we're specifically doing time checking in the main loop and in if statements. Otherwise, that would be done by the hardware on every clock cycle, while we can do other things, which is why hardware timers are much preferred. So first of all, we're gonna check if millis are greater than last reading. Actually, I should probably rename this to next reading. So if millis is above or equal, sure, why not? I don't know what the compiler is going to make of that and what is more efficient, but so if our current milliseconds is higher than our next reading, then we're gonna take our next reading and we're gonna add our reading interval. Let's do a quick check on Arduino millis. Let's just grab the reference. Unknowing. Well, there you go. Well, I wonder what happens when this overflows. Will it just stop? I have no idea. We shall see in time. Yeah, basically, here is where your timer code goes. If you are making a software timer. These 3 lines are basically all you need for a software timer. Yeah, I guess we could remove the blinking for the handle routine. Actually, we could keep that and see how it looks for now. But waste 5 of the milliseconds just having the thing on. Sure. Could do that. This is just gonna look like a LED being on, so let's adjust things to the human timescale so we can actually And see what the hell we're doing. Let's upload this. There's a cat outside my door. Probably wanting to go outside, so I'll be right back, I think. As soon as I've checked on what this thing does. It just looks like this thing is on, so let's just have it be delayed. Be right back. What is... Yeah, someone else in the house took care of it, okay. They finally woke up. Yeah, connect with the network. Okay. Let's remove these because they're obviously in the way. Probably want to delay. Yeah, this is, yeah. Let's keep like that. This shouldn't do that double beep beep kind of thing. Should just beep once a second. Tick, tick, tick. After it's got Wi-Fi, of course. Oh, there you go. Seems to be working. I was gonna say it's a bit too fast, but it feels like it's too fast to be a second. But when I'm comparing to the computer here, it doesn't drift forward, doesn't drift back, so it seems to be working. Let's just remove this to see if the handle function interferes with this. Because then it should start drifting pretty fast. Pretty darn fast. Connect to network. Yeah, it seems to stay in sync. So that's a software timer doing that blinking that you can barely see. Yeah. It occurs to me that you can't even see the timer I'm comparing to. Oh yes, you can. It's right here, it's alive. Look at that next to it. It's drifting a bit too fast. It's a little bit too fast, I think. But as long as it's consistent. But yes, let's I don't know, read, I guess. Actually, let's pop a function here. Do timer. Sure. Yes. Do timer. What will do timer do? At least I think it's in the I did buy the no, what was this thing called? Fuck it. Just search for that. Where is it? Where is it? Where is it? Where is it? Damn you. Wait, there. This is Spark from 8232. Yes. There we go. This is the thing I've ordered because it seems quite sensible. Lookup guide. Hey, first of all, let's see if we can get the dimensions of this. It's not intended to diagnose or treat any conditions. I can say that to progress. We can definitely use this to diagnose. But not treat, I don't know how you would treat conditions with a purely input-like device. Oh well. Anyway, so the 88232, it's basically integrated front line no, what's it called? It's an integrated biometrics font end. Yes, that's the words. I've looked at the schematics for this a couple of times, and it has lead off detection. That's what's LO plus and LO minus here are for. SDN is shut down. Why would they put the line above there? Oh well, we'll figure out some. So that's those 3 pins. You have lead off negative, lead off positive, shutdown, which is it shuts down the ship, useful for power saving, I guess. Then there's the output here, which probably analog, and then power, and then ground. So we only got these 3 pins to watch. Maybe I could tie this to a permanent on. I don't know, we'll solve it. 3v3 is there. The ground is there. Oh boy. I'm gonna have to check the sizes of this as well. Shutdown is not used. Is it because it has a pull up? Yeah. Kind of an odd color combination, I think, at least. I would have the arms be red and blue and then the leg be black. I don't know, it just feels weird. Art display, you say? It's literally an a oscilloscope, generic oscilloscope sketch, but what the? Okay. Wait, you can have like custom stuff. Wait, oh yes, this is processing. I see now. I thought this was the Arduino sketch first. I was like, what the heck am I looking at? Why do you need this? There's a serial plotter in Arduino. It's literally like, well, I can't use it now, but I will use it with with a physically connected board when I test it out. Like, you don't need to create a freaking processing app, yeah. And, yeah. Even, let's say, yeah, here, this is serial plotter. You dumb fuck. So, oh, I just want the freaking, yes, I will look at that. Simpler than I thought. So yeah, it's basically serial print line analog read. Yeah. Unless the lead on detection is fucking up. Well, if the ship says the lead, any lead is off, it's panicking. Otherwise, it's gonna send actual just raw value. Wow. Like 1 millisecond. Oh. I mean, I have no idea how. How precise this needs to be. Let's do this. Let's keep the LED on for as long as we do the timer code. You want to check that in there too, just so we know what the hell's going on. Maybe I should start the serial as well. Actually. I mean, realistically, we're not going to be connected to this. So we're going to be using another sketch just to test it and to find actual values. But we're going to have some sort of I guess we could take the acceleration or what's otherwise known as the integral of our readings, because it's going to be drifting up and down. So My big brain tells me that if you have a what type does analog read return? Is it unsigned? Oh my god. Sorry. If type ends. Okay. Here have an int. Now the way to to find out the integral or the acceleration of something is to just remember what it was previously and take the differences between them. That's essentially what an integral is. It checks for the differences between each, like with its neighboring points, I guess you could say. Old read value so first of all we're gonna construct a value from our we're gonna construct a new value which is going to be our analog read on a 0. Now we can pass that around and we can create a value called old read value negating new value or other way around. I want the new minus the old, I think. Yeah. Yes. And then we're gonna set our old read value to our new value. So we're actively doing this in this way. If we changed these to run like that, this would stop working. This relies on old read value being old from the next cycle at this point right here. And then we set it to the current one, and then we will come back next time. It's not set until this line again, so when we step through here, we're gonna have the new value negative the old value, which we got from the previous loop around. And yeah, that gives us a value, and that we can probably do some checks on. I could probably take the absolute of it and check if that is higher than 2, whatever, 10 for now. that'll work for now. Like this 10 here is just out of the blue. But yes, we will compile. We will upload over Wi-Fi, which is still weird to me. Come on, there you go. Blink. Connecting to Wi-Fi. Doing over there stuff. Why is it? Oh, because our reading interval is quite high. Set to 20 milliseconds. Cats are playing or something. Okay, that's a bit more interesting of a behavior. Oh yeah. Where is analog now? Oh, there. If I touch that, that's gonna go haywire. Maybe. Oh. What if I make a proper connection? What about then? So I use 0 right there. It's my little antenna in there. Yes. It seems like the integration here, integralation or whatever the fuck it is working to some degree. I can't really plot it out because, well, serial monitor is not supported on network ports. You know what? Fuck it. Let's just do. Yes, we could print like that, but we will also like to print single comma. And I'd also like to print new value, so I can make sure that it is correctical. Every 20 milliseconds we will get some 0 data. So 11,5200. I think that's standard. I do not actually completely remember. But yes, we shall upload that. Let's reduce that to like 5. Now, I'm gonna have to hook it up to USB again to actually see the plot. So let's wait until it's uploaded. Done uploading. Well, okay, there it goes. So I'm gonna lay it on its side here. I'm gonna plug it in. And then reboot it, of course. And we're gonna... What the... There. Yes, there it is, comfort. We're gonna do this. And we're gonna change to 11,5200. And there we go. There are our values. Now, that's really useless. What isn't useless is the serial plotter. There we go. Now the blue value is our raw value. The red value is our integrated value. And you'll see with the integrated value that it is centered at 0. And that's because whenever you integrate, you actually always get a plus C term. Oh no, wait. That's wrong. When you de-integrate, or whatever the word is, when you're doing the opposite, you always get a plus C term, which is plus a constant value. And that's this difference right here. And equally, so that's when you're going up. When you're going down, de-integrating, or whatever the fact it is that we're doing here. Or are we integrating? Whatever the fact. You inherently lose that constant offset. So that's one of the reasons I want to do this, is because I want it centered at 0. Now, let's see what happens if I touch this. And we see some nice negative and positive edges right there. Yeah. So, let me, that's not a comment, that's a comment. Let's upload this via USB now though. So now we'll only have the integral. Yes, the integral. That's the word, not de-integrated. So now we're gonna have only the integral showing up in our plotter here. It should be blue. No. Filter. Yeah, there we go. So now we got a much more detailed graph. Good, you're seeing this. Which means we can now see more of what's happening. Interesting. So when I put my hand on the pin, it goes down, and I take it off, it goes up. And that's currently because I'm touching the ground. If I'm not touching ground, the behavior becomes erratic. But if I touch myself to ground, and then touch the analog pin, I form a resistor to ground, so I'm naturally pulling the voltage down, which means that it dips. But then it stabilizes, so the integral goes back to 0. And then when I release, the complete opposite happens. There's no longer a resistor between ground and the analog, so the analog floats up, and thus the integral shows a positive value. But then it stabilizes, and the integral returns to 0. So yeah, we get a nice zero-centered signal. This could be at 3 volts, or could be at 2 volts, or could be wherever really in the ADC's voltage range. But by doing this integration, we are centering. We're centering it on 0, and in a way you could see it as the speed, or the not the speed, the velocity of something traveling along the graph, I guess. Integrals are weird, but they're very useful when you... I don't know, it's really hard to describe integrals. They are... yeah, I don't have much more to say about integrals. They're amazing tools. I barely myself now know how to explain them, because, like, for me at least, the only way to really understand integrals is when you get like that aha, when one dimension splits into 2, and you can finally see that how... I know it's weird to see how, for me at least, how it correlates, or to explain the correlation. So I'll just get up there. But yes, also, even though we have a delay in here of 5, which only randomly gets applied by chance, even though that is happening, the data rate here is completely stable, regardless of if that delay is invoked or not, which it fills me with confidence that I'll get a stable time frame. That's weird right there, just showing a bunch of zeros for a time. But yes, that's the beginnings of the biometrics platform, and we will collect some beautiful data with it. Yeah, that's about it. I don't know really what more I can add in terms of code right now. Also, the thing, this, when we're looking at the heartbeat later, we're only going to care about one of the edges, because if we care about both edges by having an absolute in there, we're actually going to double trigger, like, for each beat, which is not optimal, if you say so. it fucks up our values, fucks up the data. And yeah, this here is just some calibration value. Let's define that. Beat, why not? I have no idea. But yeah, basically, basically in here, here we have a heartbeat, essentially. But if the wave is slow enough, this value is going to be over some calibration value for more than one run through this timer. So I'm going to have like a in beats boolean. So if the value is So if the value is over some calibration value, and I think that's a logical and. I'm not sure. I am 100% sure that a single and is a bitwise and. So I'm kind of sure that two of them is a logical and. Anyway, I'm just trying to please the compiler. Will make its job easy, I guess. Yes, so while the value is over some calibration value and we are not in beats, we're gonna set up. We're gonna set our in beats equals true. And we can get, actually we will care about two sides of the wave. Because we're gonna check the calibration value in both, because there's gonna be a positive and that's gonna dive down to negative before it returns to 0 again. So we're gonna turn off this in-beat thing, so we're gonna enable the re-triggering when it's on the negative parts. Basically, the waveform I think that we're gonna get is gonna look something like that. Yeah. So what we're gonna do is that we're gonna, first of all, let's mark our 0. God damn, this feels so stupid. Yeah. There's our waveform, and there's our 0 that it's centered on. Now we're gonna have the positive calibration value, and whenever we are above that, and we might be above that for more than one reading, so whenever we first whenever we first are above that, we check are we in a beat, and if not, we set the beat to be in a beat. So from about there and forwards, we are in a beat. Now, how do you deactivate the beat? Because we need to be able to activate it again for the next beat. Well, We could just check if it's close to 0 again, but we would be susceptible to noise. So what we could do is have a similar, or maybe even the same, calibration value for the negative part as well. Which means that when we go below a certain point, about there, at the kind of start of the peak at the bottom wave, we will exit the beat, and we'll be ready to re-trigger it once it reaches this top level again. But it won't do that due to noise, because it's down here, which is all the way at the other end of the 0 even. So it's quite far away from the top calibration right here. Yeah, I think that will work fine. Maybe we can do something interesting by measuring the area of that, if that's even useful information. Maybe, maybe not. But yeah, that's essentially what I'm gonna do. I'm gonna implement a software Schmidt trigger. Yes, it's a software Schmidt trigger. So we have software timers and software Schmidt triggers here. God damn. That pretty much means this could be done entirely with, like, you could do this without a microprocessor, probably, if you wanted. But yes. So let's get that to the side. So we first check if we are in the beat. Well, first check if we are over the value. Then if we are not in the beat, tell ourselves we are in the beat. Which means we can only do this once. And here there will be a trig of some sort. And then we need to reset in beat. So we're going to check if value is less than some calibration value. Sure. Now, fun fact, given that these two are the same, this is modeled as a perfect Schmidt trigger, which is not the case for actual Schmidt triggers. They will have a slightly different... Also, I should probably do that. Yes. So right now it's modeled as an ideal Schmidt trigger, which has the exact same range between reset and set. But in practice, the top and bottom here there's gonna be some value difference in that. And likewise, with this one, we can only activate it if we are in beat. Likewise, but unlikewise. As you've noticed, we've basically taken this if statement and inverted it to get to here. And we're gonna invert the logic in here as well. In beat equals false. And that's all that thing needs to do. We could even throw it up like that, so it's a one-liner. Technically, we could throw that up there. And here we could do whatever routine for when there is a heartbeat. Send heartbeats. We'll do that for now. Later that will connect over Wi-Fi to a server of some sort to log the data. It should probably have like some time reference attached to it. Okay, let's try that. Oh, that's a fun mess. It's been reset. Not available when Plotter is open. Are you serious? Oh well. So this is never gonna trigger the heartbeat because this calibration value is too big. Let's do 20. So I can clearly like emulate the up down. Let's see if we close this and we can. Yeah, every time I release, it says beat. Beat, 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 beat. Oh. Yeah, it definitely needs calibration, and I hope my boards arrive soon. Yes, there was the SparkFun. Yes, the SparkFun ADE 8232. Let's figure out its size first. SparkFun. I swear Google will just tell me this. Yeah, that's the actual package of the board. I check the product page. Does not say in the description. Does it say in the documents? Oh, for fuck's sake. Okay, that's the schematic. Okay, I try to go back. That's what we're doing. Let's go to the GitHub. Let's go to the hardware. Yeah, that's the board file. Sure. I can't just drag it in, really. Yeah, that's the wrong. I can't open. I can't just open a board, can I? Why? Oh, why the fuck you do this? Hey, how about ACDA? Let's see if they support this drag book or something. Yeah, whatever. Let's it's not gonna have a JSON file. Probably EDA files. Import. Where did it import it? I have no idea. Anyway, there it is. Nice. Isn't there a tool to take measurements? Dimension. Okay. So we have a board size of 1420 mil. And 1120. So 1420. That's 1420 mil to millimeters. Are you serious? Millimeter, yes. No, what? Are you? from... Yes, okay, yes, that makes sense. It's 36 millimeters. Watch this, watch this, watch this, watch this, Google. Yes. You get it right at first. Why did I even switch to DuckDuckGo? It's so annoyingly stupid and incompetent sometimes. Actually, most of the time. I'm sorry, but that's truth. I'm sorry, Google is just better. But yes, let's get this and let's dial up 36.06, 36.06. It fits. And there's a millimeter to spare. Okay, wait. We still have the 1120. Wait. 1420, yes. 1120. 1120. 28.4. 25, 6, 7, 8.44. Wait, 35, 6, 7, 8.4. Yes. No. It doesn't fit. Yeah, it doesn't fit. What does fit? 25.7. Fucking damn it. I need to reprint this case then, I guess. Oh, wait. What did I say can fit in there? 25.7. Let's round that down to 25.5. 1003.9, so 1004. So let's see if we can shorten this to 1004. That's not what I wanted to do. Can I not move this around at all? I don't know whether... Okay, I can cut until there, on that side at least. Let's see what we have. So basically, I have to cut the pants in half, and I have to cut in on this side. I have to remove that thing. Fuck it, at this point it's just easier to print a bigger case. I think. So close, yet so far. Also, there's the resistor for the shutdown that pulls it up. I was looking for that. Thought it was gonna be a long line over here, but just went straight through ships. I was like, okay, I don't know why. There should be a pull-up there, but it's not there, but yeah, there was. I thought it said OK for a moment, but it's 10K. But yeah, I'll see what I'll do. I'll probably just modify this case. I'll modify some parameters, make it wider, and that should be it. And then I'll just reprint it. And yeah, we'll solve it. Yeah, yes, I want these to arrive. I've ordered 3 of them, and they should arrive very soon. Very soon. Very soon, hopefully. Like, I'm really hoping, because like they were due to arrive the 30th, but they didn't come then, they didn't come Thursday, they didn't come Friday. I doubt they will come on Monday. They technically have up until the 10th. But why the 10th? That's a Saturday. Oh well. Hopefully within the coming 5 days I will get the ECG project up and running for real. Hopefully. And then I can actually start answering some questions and do some data logging and all kinds of interesting stuff. We'll see what it gives. We'll see what fruits the tree bears. But yeah. Yeah, for now, basically, if I want to continue using this case, which is sized precisely after the wemos, not after this module, because it was never intended for this module, then I have to cut the sides, the long sides of this module. I have to cut the pins basically in half. I have to find a new place for this pull-up. So I don't know. Maybe it's better off if I just do something like that, like fire on off that side and then cut in here. What we need. So yeah, there's and I need to cut half of the resistors off. That's not really gonna work. Yeah, that's not gonna work. So I'm gonna have to redesign the case, most probably. But yeah, that will also allow me to put in a proper spot for the charging port or hole or whatever the fuck. Because right now it's just a box without any covers or lids or anything, and I should probably change that and update that and make it better. Yeah, I like this concept of yeah, mobile uploading and updating and stuff. And I don't know, there's just something about having, like, just the act of taking this and just pushing it down slightly into the case. It's actually a solid unit like this. Actually, like, I don't know, it's hard to describe. It gives it a feeling of a tangible, actual developed thing, because I can hold it, which is weird. Also, that marker is going away. I shouldn't probably be messing with it too much. But yes. Yeah, there's just something about having a case for your project and doing this, like, just feeling it. Like, there's one thing having a breadboard and a mess of wires and like shuffling all that around and being careful with that, but this, like, just the raw robustness of being to pick it up with one hand pretty much however you see fit without having to care about, like, that it's fragile, because it isn't, because it has a case and it's a product almost. That's kind of the thing that I'm getting at. It's so, getting a case for any project makes it 100% better, like, immediately, just by adding a box. You've increased, like, the feel of your prototype project. I didn't really know you could do that, but yeah, strange. Yeah, it's kind of like a brick. It's a battery-powered brick that will probably be on for months if I just let it. But yeah, I will drill a hole in this, and or will I? I don't know. Yeah, this will be my test case from now on. This is, or, well, prototype what's it called? This will be my torture case, I guess. The one that goes through unorthodox changes to represent the new the new measurements in the computer, I guess. So I'm gonna manually drill in a hole, and then through that hole I'm gonna set down the ESP and all that, and then I'm gonna do some measurements so I can actually precisely put a slot in there so it's actually all neat. And yeah. I have high confidence for this. It's gonna be good. But for now, I'm just waiting for these boards that has these chips on them. Like literally, that's the only reason why I got these boards. If I could get these chips assembled, like on a little board from JNC PCB or whatever, I would do that in an instance, because this is quite large and has a bunch of crap that I don't need. I mean, literally, you could take this board and cut it almost down the middle right here. And change the orientation. And you basically made a board that's better. That's smaller, at least. It doesn't have the LED or the jack or the pins for the jack, but it would expose the resistors where you can add them. This resistor could go too, but yeah, you could basically, just without any modification to the current layout, you could push this down to 1100 mils by 820 mils. Which would fit quite neatly into the little case here at the top. It would be, actually that's almost comparable to the shield size of a wemos D1, so it would almost be perfect. But since people don't even stock these as special parts, I can't get them without getting them either off boards or something like that. And I don't want to solder these myself because A, I've never done surface mount soldering. B, it's tiny. C, all of the above or something. Yeah. I just don't want to be soldering a 13 € ship as the first thing I'm surface mount soldering. Yeah, a lot of things could go wrong. So, but yes, we'll start with this. I'll see if it's possible to cut down the board like this, just straight off the bat. If it is, that would be awesome, because then I can just attach my leads here to R1, R4, and R5 here, just on there. And I'll provide the ground and 3 volts from somewhere else. Let's check the 3 volt line. First of all, you what? Okay, there we go. So that's, why is such a thick trace? Ooh. It's like something I don't understand. Wait, was that all flooded in the copper area? No, wait, that's the bottom. What's the rest of the bottom? Round? Yeah. a thick ass 3v3 volt going through the board here for some reason. But yeah, I could feed in. I could feed it in right through this video. It seems fairly acceptable, although it is right next to ground, so that would be fun. In ground, I could probably put somewhere, somehow. There, for example, probably. They've done a good job not having islands on this board, so. Ooh. I would put that there, but I don't know. Well, that's one way to route it. So just pop it through, yeah. I mean, it works. So much for signal integrity. Oops. But yes, I will stop rambling, and I'll do more. Yeah, I'll do more work on this when I get the parts, and yeah, I'll really get working with the software once I actually get the parts and all that, because that will make testing a lot easier, and all of that sort of jazz. But yes, goodbye.